This is going to be a fairly long video because it's going to have all the STAAR review examples that we did in class before we did our lesson. So be prepared to watch a very long video, or you can skip to the ones that you need to that will help you with whatever you need to do. So here is the first example that we work in class. We were trying to find the inverse of we're looking for which one is the inverse of this function. So we have worked a lot with inverse, so we can just do them mentally now. So looking at this right side, we know that there was a number x, then multiply by the x multiplied by 3, and then subtracting 2 from the product. So we're going to work backwards. This is how you do backwards. So we're going to add 2 first. So we're going to start, say there's a number, the same number now, and we're going to add 2. That's to take care of these 2. And then we're going to divide the answer by 3 by working backwards. So basically, we're looking for an expression that looks like this on the right side. And the only one that looks like that is answer choice G, okay? That's a fast and quick way to do these problems. The next problem that we worked in class was this table, this coordinates were given to us. We're looking for the inverse. So we can just do elimination process as quick as we can. So we see that this is the first coordinate is given as 2,6. This is 2,6. If you follow the rule for inverse, we're going to switch. We switch the 2 and the 6. Okay. So the first coordinate in our list should have been 6,2. So all this will be out. This is out. This is out. And this is out. So the only thing left is 6,2. Of course, we can confirm by doing the other one here. This one will be 4, -3, which is 4, -3. That works. And then -5 and 7. -5 and 7. So by doing a quick elimination process, we know the answer is C. All right, we go to the next one that we worked. It was this one with a graph. All right, so we have a graph given to us already of a linear function. So we're looking for the inverse of this linear function. Okay, there are 2 approaches to this. We can write the equation for this function from this graph, or we can just switch the x and y coordinates. So it was easier to switch to write the equation first from here. So the equation of this graph is y equals, if we look at y equals mx plus b, we will see that the slope of this line is rise over run. So it's we're going to do 6 this way, 6 up and 2 over. So that's 6 up and 2 over. That's 6 over 2, which is 3. So it's 3. So it's 3x, and the slope and the y-intercept is -6. So we've done a quick extraction of the equation of this line. The next thing now is to find the inverse of this line. So let's do a quick one. We know our inverse will have something to do with x plus 6. So we're going to add x plus 6, working backwards, plus 6, and then divide the answer by 3. So we know our answer will look like this. So we can go look at the answer choices and which one looks just like that. Obviously, it appears we don't have anyone that looks like that. But if you kind of simplify this expression here, you will see that we can separate them into different fractions. It will be 1/3 x from that, and then plus 6 over 3, which is 2. So and then we can know this is the answer from that. All right, the one that we worked in class was this one over here on the left side. We are given a linear one, a square root function here. So we're looking for what is true. So we're looking for the inverse of that. Well, you know, if you do the inverse, remember there was a number that was x. 5 was added to the number, right? 5 was added. So if we're going to do it backwards, we have to subtract 5 first. So we're going to have to subtract 5 first. And then the last thing to do is to take the square to get rid of the square root. So this one is the one that says we must subtract 5 first and then take the squares of both sides. So this is true for sure. We can do a elimination process now and see which answer choices does not have 1 in the answer in their answers. So we can see that all these don't have one. You don't have one. They're out. They are out. They are out. So obviously answer 2 is not correct, because it's saying we should take square before we subtract 5, which is not true. We're not going to take square. And then the range, let's prove number 4 wrong. We know 3 will be right because it's grouped with 1, so that 3 is right. Let's prove this 2 as right, this 3 as right, and then let's prove this as wrong. All right, so to prove this as right, we have to make a sketch of the graph that we have on number 1. That's the let's sketch this graph. So this will be a quadratic function that has been shifted 5 to the right, 5 to the right. So it's going to look like this. It's a quadratic function shifted 5 to the right. So it will be something like this, where this place will be 5. Okay. So now the domain of this, of course, is all real numbers, because it's a quadratic function. It goes all way, both sides all the time. So go from left to the right. There's no break. So that makes the domain of this inverse to be all real numbers, which is true. Okay. And then the range of this should be from 0 all the way to infinity. That's the range. Okay, let's compare that to what is given to us here as a range. Say the range is all real numbers that are greater than or equal to -5. That is not correct. It should have been all greater than or equal to 0. So that's why we put this one wrong. So the correct answer is F. All right, so the next thing is, we did this next one over here in class. We're given a function. F of x is this. This is square root function. We're looking for the range of the f inverse of x, the range of that. So to do this, we can actually do the problem itself, look for the inverse of this. So we know the first thing we're going to do is to get rid of this square root. So our answer will have something like x squared. That squared gets rid of that. And after that, we are going to add 12. We're going to add 12 to get rid of that. And then we're going to divide the answer by 3. So like that. So it will be like this at the end. So let's separate them. We'll look like this. 1/3 x squared plus 4. So now we're going to make a sketch of this. Now, if you know your transformation very well, you're going to realize that actually this is the parent function that has been compressed by 1/3 and shifted up by 4. So make a sketch like that. So it's the parent function compressed by 1/3, so it will be like tiny. All right, compressed by 1/3 will be like tinier or skinnier, and then shifted up by 4. Okay, so our final one is this blue one, shifted up by 4. Okay, that will be our inverse. Okay. Now this is square root, obviously. So it's the square root function that was given to us originally. So that goes like that. So we don't need this part. We don't need this part of the parabola. So we can just erase that. So we can erase that part because it's not part of this. So if you draw the line, excuse me, let's get that one back. So we're going to erase this part because it's not part of our function, and now this is the if you draw your line y equals x, you will see that this blue is that is the inverse of the red one, of the red function given here. So if you look now, we can compare the answer choices to see which one is true about the blue graph. Okay, so is the range all real numbers? No, obviously the range starts from 4 all the way to infinity. So that's not true. The range is from 4 to infinity. Now it says the range is from 0 to infinity. That's not correct. It's not starting at the origin, so that's not correct. And the range is not from negative infinity. It's not facing down, so that's not correct. So the range is from 4 all the way to infinity. That's the correct answer. All right, that's how you process that. The next one that is given to us is that we did in class was this one. So we are looking for restrictions. So restriction that can be made so that the domain of this function to the domain of this function here, so that f inverse of n will be a function. Okay, so what we can do first is to make a graph of this. Let's make a graph of the one I put the box around, so you can recognize that this is a absolute value function, all right, that has been reflected across the x-axis and shifted up by 3. Reflected across the x-axis and shifted up by 3. So let's make the graph. So absolute value function that is reflected across the x-axis. So this is the first reflection, and then shifted up by 3. So I'm going to draw the actual one. Shifted up by 3 will look like this. So now that is a function. Now we are trying to look for a restriction that need to be placed upon this. So we will try to cut off one of these arms of this absolute value. Okay, now let's first of all try to see how the inverse will look without any restriction. Let's use another color over here. All right, so here is 3, 0, 3. We go to 3, 0, so it will be something like this. And you know, if you do all of them correctly, you will find something that looks like this in the green. That will be the inverse. Okay, because let me just go step by step so I don't get you confused. All right, so let's plot some points and then make the graph. This look a little bit tricky. So 3, 0 becomes no, sorry, 0, 3 becomes 3, 0. So that's how I got that point. All right, let's look at this place over here. Will be negative 3 and 0. So we're gonna have 0 and negative 3. So our graph will be like that. All right, and this place will be 3, 0 will be 0, 3. So will be over here. So actually our graph will look like this. Our graph will look like this, not like I was trying to draw it. Okay, so now we're looking for restriction that needs to be placed on this. Let's consider the first option. Will it be n is greater than or equal to 0? Well, you know, if you look at this, we only want one of the branches, so we only want one. All right, so that will not work because the restriction should have been n is less than 3. All right, it has to be something that is less than 3. Both of them are going towards the left side. They are pointing towards the left side. So it cannot be this one. It cannot be this one because the vertex is at 3, right? And this graph is pointing to the left. So it cannot be 1/3 either. So it has to be n is less than 3. I'm going to make a separate video on restricting domain, which might benefit you if you watch later on. So basically, you can look at any function and try to see how you can cut off one of the arms. So if I cut this off, the domain is n is less than or equal to 3. Or if I cut this one off, it's still the same, n is less than or equal to 3. All right, so that looks like a long one. Now we go to the next problem that we did in class, which is this one. It looks similar to that. So we have we are given a quadratic function, so we want to find the inverse first of all. So we're going to do the inverse. So we have to draw the graph. Here's the graph. So s squared plus 3 is a parent function that is shifted up by 3. So it's going to look like this. All right. If you do the inverse of this, this is 3, 0, 3. It will be 3, 0. Like that. And if you know how, what we did in class before, it will look something like this. Because if you draw the line y equals x, it's going to be a reflection like that. However, because this new function is going to fail the vertical line test, so you try to draw a vertical line here, that's not going to pass. So we need to cut off one of these arms of these sideways parabola. So we need to cut it off. This is how you determine which one to cut off. All right, so if we're going to make it work, what we're going to do is we're going to restrict the domain. Okay, all right, so we're going to restrict the domain of the original function. This original function, the domain is from infinity to infinity, right? It's all real numbers, but we can cut it off by, if you remove this, the domain will be from 0 to infinity. What is left, this part that is left, is from 0 to infinity. S is greater than or equal to 0. That will help us to cut this one off also. That way, if we cut this off, this will be cut off. And now you're going to consider this, whatever that is left here, these two that is left here are the new function. This is going to be the function. That will be the inverse. This will be the inverse of the function. So now, the domain has to be restricted from 0 to infinity, because that's the domain of this new function right here. There's the domain, okay? It's from s greater than or equal to 0. So this will not be true. It cannot be all real number. That will be the original parabola. It cannot be greater than or equal to -3, because we don't have a graph here to start. So the only one is the answer choice A, in which we have one of the parabola arms have been cut off, and what is left is basically from 0 to infinity. That's the parabola that we need, and that's the square root function that goes with it. And we're looking for the domain of this, which is x is greater than or equal to 0. All right. The next one that we did in class was this graph right here. As this graph over here, we're given a function y equals 3 to the power of x, and we're looking for what is the inverse of this. So you're going to recognize that this is an exponential function. So the inverse will be a logarithmic function, logarithmic function. Okay, so if you know your parent function very well, it cannot be f, because that's obviously an exponential function. We're looking for a logarithmic function. Or if you want, you can actually do this. If y equals 3 to the power of x, and if you switch the x and y, switching the x and y will look like this. Will be 3 to the power of y, and then you take log of both sides. So log base 3 of x equals y. So we're looking for log base 3 of x. All right, so this is an exponential function. That's not the answer. G is also an exponential function that been reflected across y. That's not the answer. All right. H is a logarithmic function. Okay, and that is the answer, because it's a logarithmic function. J is exponential function that's been reflected over the x-axis. So that's not the answer. So basically, to solve this problem, you need to know your basic parent function of the log. All right, and the last, no, not the last. We have three more that we did in class. Actually, not three; it's a bunch more. So we have a pair of functions with inverses. We're looking for which one is the inverse of the other one. Okay, we go by the mental way again, right? We're going to do them by mental way. All right, let's look at this one over here. The last thing that was done was to actually the first thing that was done was square x, and then we take a half of it, and then we subtract 1. All right, we're going to do it backwards. Let's do everything backwards. That means our answer will be, we're going to add 1 first. We're going to add 1 first. All right, so we look like add 1 first. After that, we multiply everything by 2 to get rid of this 1/2. Should have been times 2 of everything like that. And then we take square root to get rid of that. So we're looking for something like that. This is not correct because the 2 is not inside with the x plus 1. So F is wrong. All right, look at this other one here. The first thing we will do is to add 3. Oops, it was not adding 3 to x. Okay, so that's wrong. It's taking the square root first. That's not what we're going to do. We're not going to take square root first. We have to add 3 divided by 4. Okay, that is obviously wrong. And the next one, say we're going to subtract 6 first. We're going to subtract 6. Okay, let's build it up. X minus 6. After that, we're going to divide by 2. We're going to divide by 2. and then we're going to take square root. We're going to take square root, which matches what is on the right. So that's our answer. Let's prove J wrong. So to do J, we need to add 5. Okay, we're going to add 5. Okay, right? X plus 5. Good. And then we're going to divide by -1. So divide by -1 will be -x minus 5. Oops, you say -x plus 5. And then we take square root. So if it was something like this, it would have been right. But now it's wrong because they did not divide by -1 there. So that is wrong. All right, so the correct answer is H. The next one is this, which we did in class. We are going to let, this is a given function to us. So we are going to find f of the inverse of 3. So let me write it properly because the f is standing by itself. We're looking for f of f inverse of 3, like that. So what we need to do first is to find f inverse of x for this one. All right, we can build it mentally like I taught you in class. So we know it's going to be subtracting 1. So f inverse of x will be subtracting 1. That's subtracting 1, and then dividing by 4. Dividing by 4. Okay, let's keep it that way. So we got the f inverse of x. So what we're going to do is to plug in 3 because we're going to do f inverse of 3. So let's plug in 3 here. So f inverse of 3 will be 3 minus 1 over 4, which is 2 over 4, which is 1/2. Okay, that's 1/2. All right, now, but that's not where we are going. We need to we're going to plug that 1/2 into f because it says you take f of whatever we got here. So we're going to do f of 1/2. All right, that means we're going to go back to the original function. Let's go back to the original function and plug in 1/2. All right, we're going to plug in 1/2. So it will look like this. It will be f of 1/2. F of 1/2 will be 4 times 1/2 plus 1. 4 times 1/2 is 2, and 2 plus 1 is 3. So the answer is 3 right there. It looks complicated, but you have to do them one at a time. All right. And then the next problem we worked in class was this over here with the graph. All right, we're looking for the inverse of this function. Obviously, this is an exponential function, okay? Exponential function. So, and that would be like our function b right here, okay? Exponential. And we're looking for one that will be a log. If we try to solve this problem, we will see something that looks like this. So let's try to solve this. So we're going to write as x equals 1/2 to the power of y, and then we're going to take to the power of y. We're going to take log to base 1/2 of both sides. So it will be log to base 1/2 of x equals y. So we're looking for a logarithmic function to the base of 1/2. Obviously, the answer, B is not correct because that's an exponential function. That's not correct. And C, let's look at D first of all. D is an exponential function that has been reflected across both x and y. So D is not correct. All right, let's look at C. C is an exponent. It's a logarithmic function that has been reflected across the x-axis. So we will have expected this to have a negative, okay, to have a negative across x-axis like that, but it does not have negative, so it's not there. It's not C either, so it's none of the above. It's none of the above because it does not have a negative, showing that's a reflection across y. Okay, the next question that we did had to do with parabolas. So we did a quick review of parabolas. So let's write the general equation of parabolas. All right, the first one is horizontal parabolas. If it's horizontal parabolas, so horizontal will look like this. Horizontal was we'll be starting with we look like this. So it's going to start with x equals, so x minus h equals 1 over 4p parentheses y minus k squared. All right, so that's for horizontal. But for vertical, it will look like this. For vertical, it will be y minus k equals 1 over 4p and then x minus h squared. Okay, we need to know this formula very well. All right, now we're going to use this formula to discover this. So we're going to do an elimination process. So let's try to first of all sketch this parabola, how it looks. So let's use the information provided. So let's draw our x and y. We're given 5, -1 as the vertex. So 5, 1, 2, 3, 4, 5, -1, -1. That's the vertex, all right? And then we're giving a directrix of y equals -3, 1, 2, 3. So if we draw this directrix like that, obviously our parabola will be facing up because it's not going to cross its own directrix. It's going to be facing up like that. Okay, that's a rough sketch. So we know this is a vertical parabola. So we're going to eliminate all of those that have x at the beginning. So B is not the answer, C is not the answer. So we have A and D left. Okay, the difference between A and D is a negative right here. This parabola is facing up, it's not going to have a negative, so the answer is A. All right, we can actually cross-check between the vertex and the directrix is 2. Our P is 2. So 4P is 1 over 4P will be 1 over 8. And that's why they got the 1 over 8 form. And then the rest is the location of the vertex, okay? So you can do a lot of this by doing an elimination process. All right, let's go to the next one. We're given this parabola. So again, what we're going to do, let me remove this and have a space to work. All right, so now we're going to sketch the parabola. Let's sketch the parabola. Sketch. All right, so we have the vertex is at 9,3, so make a sketch of 9,3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So that is the vertex, okay? And the focus is 9,4. So this is 9,4. Focus is over here. Okay, we know that a parabola it needs to wrap around its focus. So this is the vertex, this is the focus. So it's going to look like this. It's going to be facing up. And that's a vertical parabola. So, well, all the equations given to us are vertical parabola. The only difference between all of this is the location of the vertex. So the vertex here is at 9,3. 9,3. So if you look at the equation really, let's apply the equation. So be y minus k equals 1 over 4p x minus h squared. All right, let's do elimination process. So our h is 9, our k is 3, okay? So we know that we're going to do x minus 9 will be in our answer. X minus 9 must be in our answer, all right? Because that's the vertex. This one has s minus 3, so that's wrong. This one has s plus 3, that's wrong. This one has s plus 9, that is wrong. So J is obviously the answer. So we really don't need to add, we don't really need to do all of the process, all of the multiplying, plugging in. So that's just by elimination process, okay? And then we have 2 more over here that we did in class. Okay, here is given to us the equation of parabola with focus at 0, 0. Again, we're going to make a sketch. Let's make a sketch. All right. Focus is at 0, 0. And the directrix at s equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something like here. All right. All right, now that's the directrix. This is a focus. Now, if we know your parabola, this is focus, this is directrix, right? The vertex is right there, going to be in between them. So, but only this time is facing to the, it's going to be facing left, like there. Focus, directrix. So, not this, but focus and directrix, okay? And vertex is going to be between them. So vertex obviously will be at this is at 10 at 5,0. So so the parabola will look something like this. All right, let's do elimination process. We know that this is horizontal parabola, so our equation will start with x minus h, I'm sorry. Let's remove all of these distractions, and so our parabola will be something like this. X minus h equals 1 over 4p y minus k square. Okay, now because it's facing the left, so it's going to have a negative in the front, like there, like negative 1 over 4p. Okay, let's do elimination process. This one is vertical parabola, they are eliminated. This one is doesn't have the negative, so it's eliminated, and this is the correct answer. As you can see, it's so easy if you can just know the structure of the equation. Okay, and the last one is this one. We're given the vertex and the focus. So let's sketch one more time. We're given the vertex. The vertex are -4, -3, 1, 2, 3, 4, -4, 1, 2, 3, -3. That's the vertex. And then the focus is at -2, -3. I mean, as 2, 3, 2,3. So 1, 2, and 3. So -3 rather, -3. Okay. Now, in your mind, we are given the vertex and the focus. Remember, if it's a parabola, we're given the vertex and the focus, so it has to be facing right. All right, it has to be facing right because it has to wrap around its focus. All right, because we are given the focus on the right over here. Oops, one more time. The focus given to us here on the right, and the vertex is given to us on the left over here. So it has to wrap around like that. So we're almost done. We just need to do elimination process. So this is a focus. Now let's do elimination process. This is a horizontal parabola. It's going to start with x minus h. Okay, so we're going to get rid of all the vertical one. That's vertical is gone, and it's going to have positive because it's facing right. So both of what is left is positive. Okay, now the only distinguishing feature now is the distance from the focus to the vertex. Okay, we have to calculate that carefully. All right, so this is 2, -3, 2, -3. All right, and then this is at -4 and -3. All right, so if I calculate from here, I need to go 1, 2 to 0 over there, and then go 4 more, 3, 4, 5, 6. So the distance is 6. If you do that 1 over 4p, if p is 6, that will be 1 over 4 times 6, and that will be 24. So the only one with 24 is answer choice A, and that will not be correct. That will be like by 4. P will be 4, but P is obviously 6, and so the answer choice is A. I have demonstrated to you that most of this problem on parabola can be done by sketching and then doing elimination process. Well, like I said at the beginning, it's going to be a very long video for those who are absent, and they can choose which portion of the video they want to watch depending on which part of the problems they are not quite familiar with. All right,